Infinity. It's a word we toss around casually to describe big numbers, endless love, or the night sky that never seems to stop. But infinity isn't just big. It isn't even measurable. It's the concept that breaks our intuition, the line our minds can approach but never cross. Infinity is the idea that refuses to end. Imagine this. You start counting. 1, 2, 3. You can keep going. There's no finish line, no final number where someone waves a flag and says, "You're done." And that's both obvious and deeply unsettling, because infinity isn't just more than we can count. It's more than we can conceive. Mathematician David Hilbert once said, "No other question has ever moved so profoundly the spirit of man as the question of infinity." He wasn't exaggerating. To explore infinity is to confront the limits of knowledge itself, the edges of mathematics, physics, and even thought. Mathematicians had to do something quite strange with infinity. They made it make sense. Let's start with something simple: counting numbers. We call this set of numbers countably infinite. Why? Because even though it never ends, you can theoretically count them one by one. 1, 2, 3, and so on. Every number has a next. But Georg Cantor, the man who stared into the abyss of the infinite, realized that there's more than one kind of infinity. He proved that some infinities are larger than others. Consider the numbers between 0 and 1. You might think there are fewer of them because they all fit within a single unit. But no. Between any two numbers, no matter how close, you can always find another. Between 0.1 and 0.2 is 0.15, and between that and 0.16 is 0.155, and between those are infinitely more. Cantor's revelation was shocking. The infinity of real numbers, the continuum, is larger than the infinity of counting numbers. He demonstrated this using his now famous diagonal argument, showing that no list, no matter how long, can capture every possible real number. He had discovered a hierarchy within infinity itself, and that discovery almost broke mathematics. It was so unsettling that even his peers thought he'd gone mad. Yet Cantor's infinities became the foundation of modern set theory and changed how we think about mathematics forever. Because it means that infinity is not a single concept, it's a landscape. And each level of infinity is a horizon that, once reached, reveals yet another beyond it. Now imagine you're traveling through space. You look in every direction, and the universe stretches endlessly. No wall, no edge, no boundary. But here's the trick. Just because you can't see an edge doesn't mean there isn't one. For centuries, scientists have asked, is the universe infinite? Or does it just loop back on itself? If you live on the surface of a sphere like Earth, you can travel indefinitely without ever finding an edge. The surface is finite but unbounded. The same might be true for the universe, a higher dimensional version of that same principle. When Einstein introduced his general theory of relativity, he gave us a new way to think about infinity. Space isn't static. It bends, it warps, and it can even close in on itself. Depending on its curvature, the universe could be open, infinite, closed, finite but unbounded, or perfectly flat, balanced between the two. Recent cosmological measurements from the cosmic microwave background suggest the universe is flat to within a tiny margin of error. And if that flatness extends everywhere, it implies that the universe may truly be infinite. Infinite matter, infinite stars, infinite galaxies. But that also means something disturbing. If space truly extends forever, then the laws of probability dictate that somewhere out there, another version of you exists, identical in every detail. And not just one version, infinite versions, every variation of every possible outcome, all existing somewhere in the unending expanse of space. Infinity doesn't just stretch space, it stretches meaning. Now let's bend infinity in another direction, time. Did the universe always exist, or did it begin? If time is infinite, then beginning is just a local illusion. But if it had a true start, what came before it? Physicists wrestle with this constantly. The Big Bang wasn't an explosion in space. It was an expansion of space itself. Time, as far as we can measure, began there. Before that moment, before loses meaning. And yet some models of cosmology, like eternal inflation, suggest that our Big Bang might just be one bubble in an infinite cosmic foam. Each bubble births its own universe, with its own constants, its own history, its own version of time. If true, time itself may not be a single line, but an endless fractal of beginnings. This raises a fascinating question. If the universe has no end, and possibly no beginning, does time itself even exist in the way we think? Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." From a relativistic perspective, all of time exists simultaneously, a four-dimensional block where every moment is already written. We move through it like a needle through a record. Infinity then might not just be endless duration, it might be complete existence, every possibility, all at once. Infinity isn't just vast, it also hides in the minuscule. Take a line, one simple finite centimeter. You can divide it in half, and again. No matter how small you go, you can always divide further. In mathematics, this is called infinite divisibility, but the physical world disagrees. Quantum mechanics says there's a smallest meaningful unit of space, the Planck length, and a smallest tick of time, the Planck time. Below these scales, our current understanding collapses. Space itself stops behaving like a smooth fabric and becomes something granular, probabilistic, like pixels in a cosmic simulation. So which is it? Is the universe continuous like Cantor's continuum or discrete like a quantum computer? Some physicists argue that infinity in physics is a sign of an incomplete theory, a red flag that our equations have gone too far. Whenever infinity appears in physics, it usually means something's broken. For instance, when calculating a particle's self-energy in quantum field theory, we often get infinite results, and we have to renormalize the equations just to make sense of them. Infinity, in this sense, isn't a destination. It's a warning, a boundary telling us, your theory ends here. Our brains aren't built to grasp infinity. We evolved to throw spears, not to ponder endless sets. And yet, infinity keeps showing up, in math, in physics, and in the architecture of reality itself. The ancient Greeks already saw the problem. Zeno's paradoxes questioned whether motion was even possible if space and time could be divided infinitely. To cross a room, you must first cross half the distance, then half again, and so on, an infinite series of steps. How then do you ever arrive? The resolution came much later, with calculus. By understanding limits, we learned that an infinite series of diminishing steps can sum to a finite distance. Infinity doesn't forbid motion, it enables precision. Without the concept of infinity, calculus, and thus modern science, wouldn't exist. Infinity is the ghost in the equations, shaping everything from planetary orbits to population models, from fractals to financial systems. It hides in every exponential growth curve, every horizon we chase. Now turn inward. Infinity is not just a property of the universe, it's a property of thought. Your brain, finite as it is, can generate endless ideas, endless memories, endless dreams. You can imagine a number larger than any number you've thought before. You can conceive of worlds that do not exist. Consciousness, in its ability to reflect and project, might be the closest thing to infinity we'll ever touch. Neuroscientists still don't fully understand how a physical brain gives rise to the infinite landscape of the mind. Each neuron fires or doesn't, binary like a switch. And yet, from these finite elements emerges something continuous: awareness, imagination, meaning. Philosophically, some have argued that the human mind might be a microcosm of the infinite universe, that consciousness and cosmos mirror each other. As the physicist John Wheeler once proposed, the universe might not even exist without observers to perceive it. Perhaps infinity isn't something we look at, it's something we participate in. Your awareness could be the universe contemplating itself, endlessly folding back in reflection. Infinity has always been both inspiring and terrifying. It's the promise of endless exploration and the reminder of how small we are. To a human being, infinity is humbling. We occupy a vanishingly small slice of time in a vast, perhaps boundless, universe. And yet that awareness, the fact that we know we are small, is what connects us to the infinite. A photon can travel forever and never know it, but you can imagine forever. That alone makes you part of it. Every choice you make, every word you speak, every life you touch, they ripple through the infinite web of cause and effect, like tiny waves in an endless ocean, fading but never truly disappearing. Infinity is not far away. It's the context of everything you've ever known. Infinity teaches us two profound lessons. First, limits are illusions. Every time we reach an edge of understanding, in math, in physics, in philosophy, infinity reminds us there's more beyond. We never arrive, we only expand. And second, the finite and the infinite need each other. A song must end to be beautiful. A life must be finite to feel meaningful. Infinity gives context to finitude, just as silence gives meaning to sound. Perhaps infinity isn't a destination, but a dialogue between what is and what could be, between knowledge and mystery, between the known and the unknowable. Infinity is not just a number or a universe or a line that never ends. It is the essence of curiosity itself, the urge to keep asking, keep searching, keep reaching beyond what we can see. From the smallest quantum to the largest galaxy, from the first spark of time to the last flicker of consciousness, infinity surrounds us. It is the horizon that recedes as we approach, the thought that never finishes forming. So the next time you stare at the night sky, remember this. Every star you see is a point in an unending field. Every question you ask is part of an infinite conversation. And every moment you live, no matter how small, is infinite in its own way. Because you are not a finite being in an infinite universe, you are the infinite experiencing itself for a moment, and that moment is forever. This is the end of today's video. Thank you for watching. If you enjoyed this journey, please subscribe to Down the Rabbit Hole with Eddie. See you in the next video.